Hi there, and welcome back to Severe Weather with Mr. CB. So, we're actually going to be getting into some specifics of severe weather now, after we've gone through those thermodynamic processes and different things in these first lessons. Now, we're going to really talk about what is severe weather. So, severe weather is weather that poses a risk to life and or property. That's the official definition, and types of weather that we can think of. Of course, thunderstorms, hail, we can have high winds, we can have tornadoes. So we're going to talk about all of these, of course. And for severe weather to occur, we need four ingredients. It's going to be shear, lift, instability, moisture. The acronym for that, to help you remember, is SLIM. And severe weather that these four ingredients can be presented due to certain mesoscale or synoptic setups. And when we're talking about mesoscale or synoptic setups, at least um, from a synoptic standpoint, we're thinking of a large area and what's going on at a broad level. So the first ingredient in SLIM, shear. So, what is shear? Shear is a change in wind speed and direction with height. That's the definition of it. And um, when we have shear, um, we have an increased longevity of convection occurring. So that would make sense why that would result or be a factor in severe weather. Now, we can have two types of change in direction with height. If winds turn clockwise with height, that's called a veering wind profile. That's what's associated with severe weather. And um, we have warm air advection in the low levels when this is occurring. A backing wind profile is the opposite, where winds are turning counterclockwise with height. And we have cold air advection in the low levels. Lift. So if we have lift occurring, like parcels being lifted, this can occur from frontal boundaries, convection, orographic lift, and vorticity advection at the 500 millibar level, or warm air advection at the 850 millibar level. Instability. Instability, we just talked about that in the last video. Um, Tendency for air parcels to accelerate when they're displaced from their original position. Um, We care about the acceleration upwards, though. This is the acceleration that we're thinking of when we're talking about stuff like CAPE. Then lastly, moisture. Moisture, uh, we can have moisture advection that influences the chance of severe weather, but increased moisture at the surface is going to result in greater instability. And why that is that we have a lower LCL and LFC, so it's easier for a parcel to eventually rise on its own. Decreased moisture in the mid levels results in steeper lapse rates and stronger winds with evaporative cooling. All right, now let's just talk about what is a thunderstorm. You can see in the background of this presentation a picture of a thunderstorm. Um, I took that picture back in 2020. It was a nice setup that we had that day. But at the root of it, really, what is a thunderstorm? Well, it's a storm that produces thunder. Obviously, you might think. And thunder is a response to lightning, which we're going to talk more about lightning later on in future videos. But generally, there are three types of thunderstorms. We have non-severe thunderstorms. Um, or these are really categories that when we're talking about types of thunderstorms, that will be a later topic. But non-severe has winds of less than 58 miles per hour, hail less than 1 inch if there is hail. Severe thunderstorm is going to have winds of 58 miles per hour or greater. If hail is present, hail of 1 inch or greater, possible tornado. Significant severe has winds of 74 miles per hour or greater if hail is present, 2 inches or greater, If tornado is present, then it could be EF2 or greater. So tornado, or sorry, thunderstorm life cycle. There are three main steps in the thunderstorm life cycle. So what happens? First, we have the towering cumulus stage. So we are going to have solar heating at the surface occurring, and we eventually have strong updrafts. Um, cumulus cumulus clouds are forming because of there's significant surface moisture, and they end up towering and growing, um, and they are occupying a deep layer. And like I said, there's strong updrafts that are occurring. At the mature stage, we're going to have a section that's clearly defined of updrafts and downdrafts. Here are the seven main steps, if you want to say. So first, cloud droplets collide and coalesce at the top of cumulus towers. Um, Droplets grow into raindrops. They gain speed as they fall, causing drag in the surrounding air. Then there's evaporative cooling taking place. The air density is going to increase, and then there's acceleration of mass. The acceleration of mass creates downdrafts, and like I said, there's going to be two clear sections of updrafts and downdrafts. They become well defined, and eventually there's going to be enough cool air in the downdraft that um, to undercut the updraft that removes the buoyancy. Then we get to the dissipating stage where now we only have the downdraft because the updraft has been cut off. We have cool, dry air coming from the upper levels, heaviest precipitation at this point, and because of the heavy precipitation occurring, we no longer, like I said, can have rising parcels because of how much precipitation is falling, and eventually the thunderstorm will subside or die, if you want to say. Um, Surface winds end up increasing at this time too, and the downdraft increases or decreases in intensity as the precipitation is removed. That's going to be it for this video. Thank you for watching.